Hi everyone, this is Jackie Bento and I'm here to present to you my Genius Hour project. I was working with a small tilapia fish in the Innovation Lab, and I'll explain more in depth about what I was doing with the fish throughout the presentation. My inspiration for this project was incorporating the fact that I'm in AP Environmental Science right now, and I feel it's very intriguing to study organisms in their natural habitat through the process of fieldwork, so I knew the Innovation Lab would be the perfect fit for me. It just so happened that the tilapia were going to be transported to the Innovation Lab on October 22nd, and I was really excited because not only was it the first time the fish were in the Innovation Lab, but my project would be the first data collection analysis on the fish. So what I am doing. I'm working in the Innovation Lab weighing 12 small tilapia fish in the tank each week, each Thursday for 4 weeks, October 22nd to November 12th. My point of interest is to measure the weight of the fish over a span of 4 weeks. It is also important to note that I'm using the previously established methods of weighing the fish that the Innovation Lab uses to weigh most of their smaller fish. I wanted to incorporate the normal process to see if I can help to later improve any of these methods that would help the Innovation Lab out in the long run. So my hypothesis, or in other words, my driving question for this project was that over a span of 4 weeks, will the 12 fish measured each week increase in steady amounts, or will the data be so spread out with a large range? And by large range, I'm referring to whether some fish will have large increases in weight, while others may not increase at all, showing that some are receiving more nourishment than others. Will there be any noteworthy factors, confounding variables that may greatly affect the weight of the tilapia fish? So collecting the data. Here is a short video clip on how I've been collecting the data on the tilapia. Now setting the scale. Now the hard part, catching the fish. Now weigh the fish. Put the fish back in the tank. And lastly, write down the data. So starting data. There was 52 fish that remained in the tank at all times. The probability is 1 out of 52 to choose one fish at random. The control group is a constant amount of food each day. The explanatory variable X is the time each week. The response variable Y is the weight of the tilapia fish. So actual data. It was difficult for me to decide which type of graph to use because there wouldn't be any obvious pattern unless by a chance occurrence, because each fish was chosen at random. For the dot plots on the left, these represent the 4 individual days of data on the tilapia. The graph in the upper left-hand corner is from October 22nd, which was when the first fish were transported into the tank, so all the fish were relatively the same size, between 5 and 7 grams. By November 5th, which is seen in the lower left-hand corner, shows how some fish were still as small as 5 grams, while others as big as 30 grams. So did some receive more food than others, was my question. The graph on the right just shows all of the 4 graphs combined into one, showing how the first day all the fish were relatively the same size, and then as the weeks progress, larger ranges were seen, and this could be for various reasons or confounding variables. The patterns seen in these dot plots cannot be attributed to a certain thing or variable because the events did happen by chance. So here's a before versus after picture of the fish on day 1 of the first week as seen on the left up until the 4th week, which is seen on the right. It's really hard to see them, but on the left the fish were so small, concentrated near the bottom of the tank. And on the right picture, though, you may be able to see that some are really small while others are a lot larger to help show the competition amongst the fish. My non-statistical conclusions. So from an AP Environmental Science perspective, the confounding variables of competition, resources, and space may be factors affecting the weight of the fish. For one, the fish compete for the food when it is poured in the tank. Second, for the availability of resources, no algae or plants are provided in the tank, which are producers that provide nutrients, food, and shelter for the fish. And last, in terms of space, about 52 tilapia fish were confined within a tank occupying the same amount of space. So for my statistical conclusions, the pattern seen in the dot plot cannot be attributed to a certain thing because the events happen by chance. Confounding variables may have affected the weight of the fish, but a further experiment would need to be executed to pinpoint a specific confounding variable. Taking out a fish from the tank is considered an independent event from the next fish that was taken out, based upon the fact that the fish was put back into the tank prior to taking out the next. The problem here is that the same fish may have had the possibility of having been chosen twice. How this will lead to further research. I came up with these various ideas to try to incorporate in my next project, but haven't decided yet which I'll be doing. I need to figure out ways to equalize the proportion of tilapia fish receiving equal amounts of food by dividing the tank. I could input a new explanatory variable like plants to see if it has any effect on the weight of the fish. Or I can come up with better ways of weighing the fish in general. Or I could even try segmenting the tank to keep track of the fish taken out. So these are all my ideas, so I'll need to talk to Mr. Gardner to see if these can be carried out effectively. So stay tuned for my next quarter project to see what I decided to do. Thanks for listening.